Hey everyone, in this episode, I speak with HT Moore, the creator of Metasploit, about how we got into computers, how the cybersecurity world evolved from underground hacking to heavily commercial industry, and what it really takes to build tools that really matter. We talk about why you don't need to know everything to survive in security, the real reasons behind Metasploit design, the challenges of open source versus commercial software, and what HT is working on today with runZero around asset discovery and attack surface visibility. This episode is useful for anyone who wants practical, experience driven insight into security careers, tool building, and how real world security problems are solved beyond just web and network testing. This is a cybersecurity podcast where I speak with people working in security areas that are not usually covered, with every episode focused on learning from real experience. This is Abhisek, and you are listening to the Abhisek Cast. Hey, HT, welcome to the show.
Thank you. Thanks for having me.
So, would you mind going over your early days of a career where before cybersecurity, what were you into? Like, I've seen a couple of episodes where you were a lot more into dumpster diving, picking up a lot of things and doing a lot of interesting stuff. I would like to know how was your earlier journey before cybersecurity? What made you cybersecurity being your curiosity part and things like that?
Sure. So I grew up with not a whole lot. Like, didn't have computers in the house, didn't have money to buy computers. So most of my early exposure to either computers or dialing up or internet or connection was always through a school or a friend's computer or something like that. So early on, I really liked computers much more than any other class. Like, I like the fact that when you make a mistake, it is always your problem. It's always your mistake. Computer's not going to make a mistake. It'll be your fault. So it was kind of a nice to have something where it wasn't a teacher saying they don't like your story or somebody saying they don't like how you did your art. It's very much like, no, you typed this code in and the code is wrong or the code is right, and that is it. So I like the fact that it's just very clear cut. Like, you are either doing something correctly or you're not, and you can keep iterating on that to get better. And it's fun, kind of, I've always liked to build stuff, but I've also been really bad at building physical things that don't fall apart. So I thought it's really neat to build software where, you get something wrong, you just undo, you do again. And the most fun part, I think, for me about just being in computers at all is being able to share that stuff. It's being able to, take a program someone else wrote, maybe modify it, clean it up, make it do something new, share it again with everybody else, or build kind of my own tools that I was building because I thought it would be, here's a problem I'm trying to solve, and then share that with other group of people, and then hopefully have lots of other people contribute back and build on it. So kind of that was the beginning of getting into computers and getting into open source.
Right. So when you take cybersecurity in a larger scale, it has been always been a field where after a while there has been burnouts in a lot of different people life, right? Because the information that is coming around is every day, and a lot of information that is coming from different sides. So how do you keep yourself driven on those parts, and what makes you stay on cybersecurity in a long run?
Sure. In the early days, everyone felt like a fraud because there was so much to learn and nobody knew very much of it. And you could go very deep in one or two areas, but if you said you were in cybersecurity, they would assume you have to know everything about cybersecurity. Like, okay, you have to know how COBOL works, you have to know how SQL works, you have to know how buffer overflows work or C memory allocations.
Right.
And so, even in the early days, it was very clear that if you called yourself a hacker, well, you had to know all these things. And it's just gotten worse from there. Like, the world's gotten bigger, technology has gotten broader. Now you have folks that may say, "Oh, I'm a hacker," but they really just mean I do web application security testing, or I do network protocols, or I do whatever happens to be. There's a lot of different ways to say that you're now a hacker or a computer security person that don't necessarily involve claiming you know everything. Like, I guess the early days where it was really difficult not to do that. So in a lot of ways, it feels like the world got a lot bigger. It also feels a lot harder to keep up. But the key piece there is that you're not supposed to know everything. You're supposed to hopefully spend a lot of time and learn something very well so that you know a little bit more about one thing than maybe your peers. But that's it. Then everything else, you rely on your peers, you rely on research, you rely on going to conferences, talking to people on Slack, IRC, etc. And that's really where the community part comes in. It's like, if you want to know more than just the one area you can learn by yourself, you really have to interact with the rest of the community to get it.
Right. That really makes sense. So being on this field for a long term, so starting from the yearlies of 2000s and staying right now, so what do you specifically see cybersecurity has changed from that part, and what is the upper side and the downside that you usually see in that?
Sure. The biggest change was kind of in the late 90s, early 2000s when we went from security being a thing that was absolutely criminal. Like if you knew security, if you knew how to do a pen test in 1997, it is not because you were following the law. Like there were no jobs. So if you were good at breaking into something in 1997, 98, 99, even 2000, more than likely you were breaking into stuff in your free time and for computers that obviously you didn't have permission to do so. And so it really came out of underground. It really came out of folks who explored computers and built exploits and built tools because they thought it was fun and they're also willing to risk going to jail for it. And then that shifted. Then by early 2000s, folks realized that, hey, you can actually make a lot of money being in a security company selling security products. And that, helps get a lot of people who are in the community jobs. It also soured a lot of people. A lot of the early hackers who didn't want to go that route, who really wanted to treat security like this kind of pure, fun, blue research thing, and didn't want to commercialize, kind of fought back. And there was this kind of little turf war that happened in the kind of early 2000s where the folks who were anti-commercial went by a bunch of different names, had a bunch of different groups, but they were constantly hacking and dumping the mail schools and generally DDoSing and ruining the lives of all the folks who were doing security for their jobs just because of that split. And, I understand the kind of feelings on both sides there. Like, I was kind of on both sides of that fence. Like, I understand that, I, you know, it's not fun to see everything commercialized and turned into just another thing. The other half, though, like everyone needs to eat. Everyone needs a job. You can't really fault somebody for getting a job and building a company doing what they know best, which may be building exploits, doing security work, etc. So, all that kind of early drama really split the community. And then going forward, we've actually seen it get a lot worse. We've seen, um, like a great example is, many years later, two folks I don't know reached out on LinkedIn. They're like, "Hey, we want to start a security company. Can we chat?" It's like, "Sure, yeah, yeah, how can I help?" I do that stuff all the time. Like, if you need help, how do you set up your company? Like, how do you navigate like tax stuff? Like, I can help with a lot of that. Just how to do it. And their take is, well, we used to be investment bankers, but we think security is really hot right now, so we want to be a security company now. I was like, so do you like security? Do you like anything about the thing? Like, do you understand it? It's just something you want to go solve? Like, no, it just seems like a great software business. And I just kind of like froze. I'm like, I can't have, there's nothing I got for you. Like, I don't want to support this in any form. Like, but that's where we are. We're the place where if you look at, I want to build a software company or I want to make a bunch of money, and you look at where your different options are, building a cybersecurity company is one of the fastest paths to building wealth, regardless of your background,
Right.
regardless of whether you care about security at all. And so we see a lot of folks joining the company. We see a lot of companies that are very much just big commercial ventures that are just software companies that are kind of cosplaying as security companies.
Right. That really makes sense. So you started Metasploit very long ago, and that was an open source project, if I'm not wrong. So
Yeah, that's right.
what was the design decisions that you made when you wanted to build Metasploit? Because there were a lot of hate that came around you when it was started, but even today it's been used as a very useful tool for penetration testing and a lot of different activities. So what was some of the design decisions that you took when modeling for Metasploit that really made sense for the long run?
Yeah. In the early days, kind of with that drama I was talking about early on, folks who didn't want to see security commercialized, those folks really did not like Metasploit. They thought Metasploit was a open source collection of exploits, but also shellcode, encoding, evasive techniques. The goal was to basically break every security product. So every time somebody came up with a new firewall that's supposed to stop an attack, we'd say, "Ha, look, we can just modify this bit and we bypass your firewall and it doesn't work." So we kept the IDS, IPS, the detection services very busy trying to keep up with the stuff. Then later on, antivirus, anti-malware, Metasploit even today has tools for automatically generating polymorphic payloads to bypass A/B detection, all that fun stuff. And we did that because you had to. Like if you're doing a pen test, the customers are going to have an antivirus. Like you have to bypass it. It's just a fact of life. You have to build those types of evasions. So we got a lot of hate from people on the corporate side too, saying, why are you making it easy to bypass security products? And our point is like, well, the security products suck. Like you should know that you can bypass them. It should not be something where you depend on these tools to do what they say because they literally don't do what they say. They will not stop an attacker who spends 5 minutes more on this encoding transport protocol, et cetera. So we got heat from, the large software vendors. We got heat from the black hat hackers. We got heat from the experts who thought it was dumb for us to make it so easy to use exploits. And then 3 or 4 years later, no one cared anymore. They're like, "Hey, this thing's great. Like, this is awesome." Like, it got to the point where like friends of mine who just wouldn't go anywhere near Metasploit because they thought it was a stupid tool were finally like, "Dang it! I needed this one module for a pen test, and it was easier to use Metasploit to figure it out myself." Like, yeah, that's the whole point. Like, share knowledge, share community, and have a license where you can build whatever you want to with it. So when we commercialized Metasploit, it was a kind of a different route than other companies took. These days, we see a lot of kind of really backwards commercialization where folks start off being open source core, like MongoDB is a good example, or Redis. And then they changed the license to say now all the new code is under commercial license only. You must pay us if you want updates. Or NatSD Group is doing some awful things with commercial licensing right now around their open source core. We didn't do that. We said, great, everything in Metasploit's staying open source. We're going to keep building it, keep investing in it, keep making it great for everybody. And then we're going to go build something totally new. We're going to go build this different software stack entirely. That's Metasploit Pro. And while it uses Metasploit framework, it's a ton of new modules, a ton of new functionality. It builds on the same ecosystem, but it's new code, right? We're not trying to charge people for things that already existed. And that really is the hard part. When folks get open source commercialization wrong, they try to say, well, I've been working on this for 10 years. The world owes me money for it. And no, they don't. They don't owe you money at all. It's free software, right? You've already decided to give that away. Like you can't charge for something you've already given away. And that's kind of like my core belief for open source. What you have to do instead is the hard part, which is go literally build brand new software that is closed source and sell that, and hopefully use the money from that to keep supporting open source. But supporting open source of Metasploit while we're at Rapid7 cost the company a lot of money and didn't really support us that much. There wasn't really that much benefit to it in the near term. Uh, so that's kind of one of the challenges there, is that you really don't see a lot of benefit from supporting open source, even as a commercial business. Because yeah, it's great to get some users here and there, but the users who are using your open source free software are typically not the users who will pay you money. And pen testers or red team folks are like, I don't want to say the worst customers on the planet, but they're customers who generally like to build their own tools, and they don't really like paying a lot of money for the tools. And in the case of consultants, they often don't have a lot of money to buy the tools, right? Like, I mean, Burt Pro did fantastic because it's one of the few tools that became affordable. You can actually afford to buy the license. Even then, a lot of people use that proxy instead because it's still pretty expensive. IDA Pro is another example of just a horrifically expensive tool that was used for exploit development, malware research, things like that. And it wasn't until Ghidra and Binary Ninja came along that the rest of the world was able to participate in that type of work using quality tools. So there's a little bit of gatekeeping that was out there for a while in terms of you must have this much money to be able to play in this world, to use the best tools. And we've kind of seen that crumble. And we're finally down to a place where some of the most popular tools are actually now the most affordable too. But again, if you're trying to build a multi-million dollar business by selling $300 a year licenses, good luck. That's a lot of licenses you have to sell. Where a typical enterprise software deal is $25,000, $100,000. Like you don't need to sell as many of those to be able to support a large company. If you're trying to sell, smaller priced software, you have to sell a whole lot of it to support your business. And so it's really much either a volume game or it's the enterprise game you want to do it.
Right. So, to think in an company or an profit making point of view, say a person has to build an open source product that's really useful, not making it commercialized initially and just making it open source for a while, say, or a year or two, and then using the audience and the popularity which had come through the open source tool and then going commercialized would make more sense rather going right to an commercialized standpoint. Will this be a right statement to put out, or would you have any other opinion on this statement?
Yeah, it's an experiment. So my current company, runZero, started 7 years ago, and the idea was we want to try the opposite. We want to say start with closed source software, build a business out of it, and then use that to support open source software. So kind of going the opposite direction. Instead of Metasploit, which starts open and then building commercial, let's kind of go the other direction and see how it works. And I definitely miss building in the open. I definitely miss like having lots of feedback early on with the code, working with more people. But the amount of drama it saves me, it's amazing. Like early on, just the amount of drama we'd have with people fighting over, why I want the code to work this way, or I don't like this, or you guys wouldn't accept my PR. It's like, yes, we want code that's in the product to look a certain way, especially if the code you're accepting goes into a commercial product. You have to be really picky about what pull requests, what contributions you take. There's also licensing challenges. Like if you copy some GPL code, you can't submit that to a non-GPL project and all that drama. So going closed source first was much easier. Like for me, it was just kind of a breath of fresh air to get out there and just be able to build what I want and not have a million people picking apart as I was doing it. The downside though is how do you get people to use it? How do you get feedback? So the best part about open source software is really the amount of feedback you get in the early days and getting people to help you build the software. Because anybody who can download it can help you out at that point. So we took kind of a middle ground. We said, you're not going to be open source, but we really want all that feedback from the community. So we ended up creating a free version of runZero, and that's been kind of a mainstay. So we have about 30,000 users just on the free side. And those folks give us great feedback. You can do external scans with it. You can do phone scans. You can do password discovery, all kinds of cool stuff. So basically every feature of the commercial product is available for free users who have home labs and things like that. And that's been a good kind of middle ground. And then as we get bigger, we've been trying to contribute more to other projects. We started doing integrations with, Bloodhound, with OpenGraph. We started working with the Netbox team to figure out how to bring data into Netbox better. We've been working with the project discovery folks to either bring features back into nuclei or help with new vulnerability coverage. Obviously, not going as fast as I'd love to. I'd love to do a lot more, but the goal is really to go now. Now that we've kind of actually succeeded in building a business, now go support the other open source tools we love.
Right. So I can clearly see that you are more of a person who likes to build open source stuff and recently had not been like much active in that field, but you definitely wanted to do open source things. So what basically makes you driven on keeping building products open source? Was it the earlier stage where you were able to use the code that were publicly available or the resources that was accessible without like paying a hefty amount or something like that? So was that something which keeps you driven, or is there something else that I'm missing out?
Sure. Yeah, I mean, I like making kind of open source stuff better. So I feel like, especially if we're going to use someone else's open source code in our commercial product, we want to make sure that, before anything else, we want to make sure that code is safe for our customers, that we're not going to ship malware, that it's going to work the way we want to. And any work we do to make that better, we're going to turn around and share upstream. There's no reason for us to hide that. Like, I'll give you a really silly example. Nuclei right now has a headless mode for doing headless browsing with Chrome to do different security testing. So it uses an actual instance of Chrome to go browse stuff and do JavaScript things, do all the things you can't just do with like a curl request or a network easily because you need a full JavaScript interpreter. So working on the code, we realized that the one of the sub dependencies for it is GoRod, and then GoRod has a dependency something called Leakless. And Leakless was dropping files onto the disk that were triggered as malware on Windows. And this has been like this for like 6 years. They're not actually malicious, but if you try to run nuclei headless on, let's say, a Windows computer, your antivirus is going to start screaming and then delete all your data. And that's not a great thing. So we're working on kind of a rewrite right now, Go rod code to get rid of that layer and make sure it doesn't trigger the time malware, clean up a few things, make it a little more, fix some bugs, and then hopefully bring that back to the nuclei team. Is like, here's a better headless model you can use instead and contribute all that back. And then, of course, our personal, a greedy version for doing that is then we want to build on top of the headless package. We want to start doing more vulnerability checks that we can then ship both publicly in open source, but also for our own product that uses headless in a way that's safe.
Right. That really makes sense, gives me a lot of different perspective on that part. So since we started talking about runZero, I have an question around what is the problem that it is actually trying to solve. Because runZero is into attack surface mapping, understanding how the assets, different mission that is inside each and every infrastructure. I've been encountering this question with multiple guests, and this been seems to be an question that seems to be solved. I mean, people are trying to solve that for a very long time, and it still keeps to be a very big problem. So, why is the problem of the inventory management is so hard in IT industry?
Yeah, I guess I'd frame it as like you have to do the base layer correctly or you can't build anything else. So if you were going to build a security company, the very first thing you need to know is what are your assets? What are we actually looking at? What's your website? What's your domain? What are your IPs? How many devices do you have? Where are they located? What cloud providers do you have? Like until you start getting a list of all those things, there's really nothing you can do for the customer. You cannot tell them what's exposed. You can't tell them what they need to worry about. You don't know what's end of life. So you have to have that base layer discovery to be really, really good before you can do the basic level of security. And that's unfortunately not true. Like most security products don't have great discovery capabilities. They do just enough to be able to sell the product, or their scope to be much smaller. So, a good example of that is a lot of our customers will have a vuln management solution in place, like Tenable, Rep7, Qualys, and typically that vuln scan only covers about half of their total assets, only half. And it's like, well, great. What are you doing with the other half? And why are the other half not there? And oftentimes it's because either they don't know about them, it's a new network. It's a new set of assets. Whoever set them up didn't tell the team about it. Discovery scans were too slow, or they're crashing things, or they had to exclude a lot of stuff because of the impact to the network. So there's a bunch of reasons why folks are not doing security monitoring of their entire enterprise, and that's really what we set out to solve. Is how do we go into a place and help you find everything at once, like just one shot, quickly, painlessly, safely, identify everything, whether it's in your factory floor, whether it's in your office building, or your mobile devices on the road. And so it's a mix of active scans, passive discovery, connecting to different infrastructure. And once you finally have a list of all the stuff, then you can start answering the really good questions. Like, how many of your desktops are missing anti-malware? How many machines are not being covered by your vulnerability scanner? How much of your stuff is end of life where it's running a vulnerable version of this protocol or web application or whatnot? You can't do that until you have a starting list. So I think a lot of folks they really struggle with that initial discovery problem. They all assume somebody else would do it. There's a nice burst of companies called the space was called CAASM or CASM, and that was a company named Exonius that kind of kicked that off. And their idea was that they would use integrations to collect data from everything inside your environment and then give you one big list of all your stuff. Like query your DNS logs, look at your DHCP server, go into your MDM or EDR and pull logs out of it. And that was great. But even that approach would miss a lot of stuff because there's networks that even those systems don't know about. So our take with customers is like, kind of where this came from is I was doing pen test work before starting the company, and we'd have to do the same test for the same company every quarter. And it was tough. Every time you go back, you have to find a new way into the network because they fixed everything before. And you're just constantly trying to find something else that they don't know about. And customers who have, budget for security and really care about security, like they're anything that they're actually aware of, they're going to do a really good job of security. So your best take is to find something that they don't know about, and that's always going to be the easiest way into the network. So that just kind of became the mantra. It's like, okay, how do we find something new every time? And that's really what kind of drove the mission behind runZero is like, we want to go find stuff that literally nothing else can tell you about just by being really clever with network protocols, finding multi-homed assets, SQL-sided scans. And the main thing is it's unauthenticated and you don't need permission from anybody to do it. You just run the scan. And you could tell it's written by pen testers because the product, you can just take our binaries and drop them on like an IP camera or a Windows desktop. Like you can actually drop discovery agents almost anywhere. And it doesn't really matter what the OS is. Like it lets you kind of change your perspective and pivot around the network in different ways. So it's kind of a neat approach, kind of like taking the pen tester approach to lateral movement, but using that for asset inventory and discovery.
Right. That really solves a lot of problems on the inventory management, and all the best for that, because yeah, that's an hard problem that you're trying to solve. And so since we are talking about different phases like the Metasploit and the company that you're running right now, and there had been a lot of behind the scene that would have happened which people might not know. Is there any interesting story, say, and research study, or something that you encountered to be interesting and that you wanted to share?
Sure, there's a whole bunch of funny stuff that happened in the years. We'd have folks who would contribute to Metasploit under like random handles, and then many years later, they'd come back and claim their exploits. I'd say, okay, 10 years ago, I couldn't use my real name for these because I had this job, the government, and now I'm going to come back and put my name on all of them, and I can use it as a reference for my job. And that's great. So it's neat to see people like contributing, even when they're working at places that wouldn't support it. They used the handle temporarily and then came back and pointed to it. So enabling that was really cool. Whether we wanted to or not, criminals were going to use Metasploit. So we'd often have weird interactions with folks who are, running lots of crime stuff, right? Like there was a exploit for the EMF vulnerability back in like it was like December of like 2006 or something like that. Um, and I had this kind of conversation with somebody with really broken Russian written text. And finally, he just sent me a picture, and the picture was this guy in like a hoodie and track pants standing in front of a Mercedes Benz, very very expensive car, in front of the Kremlin in downtown Moscow, with a license plate that had like a certain sequence of characters in the license plate. And finally, he's like, "Look at the shellcode." It's like, "Oh, look at the EMF shellcode that came out that started the whole exploit." And his license plate was encoded as OX90 XOR encoded into the very last 8 bytes of the shellcode was this guy's license plate. So it's kind of funny when like, this is an exploit that was found in the wild, mass exploiting people, and then Metasploit found it and we added an exploit for it over the holidays. And then everyone threw a fit that we had an exploit for it when it was already being actively exploited. So that was kind of one of the normal occurrences is that people would get mad at us because we were chasing what bad actors are already doing publicly and sharing the same tools. But it was really interesting to see, like, okay, here's the person who actually found and sold the exploit in the first place, and he kind of tagged it with his license plate and sent me a picture to prove it. So, kind of interactions like that, where you kind of see people all over the world, and you kind of see kind of like the underbelly, some of the cybercrime stuff as a result. But yeah, it's a wild world out there.
Right. That really makes sense. And going forward with some of the questions that I had on the bug bounty phases, because you have been into bug crowd and it's been a very well popularly known and bug bounty platform. And recently bug bounty seems to be a very hot platform because specifically into the bounties part, because many people try to chase money, but the traditional the approach towards crowdsourcing vulnerability like finding was the initial idea of bug bounties. So being a person who was into an bug bounty company, so how does a bug bounty company see and program like, and why do companies like doing bug bounty programs rather than having an multiple agency or an top level agency penetration test team to rather test their products? So what makes, like, what are the unique proportion does an bug bounty company bring to the end customers?
Sure. I don't work for a bug bounty program, but I think I'm still, I was an advisor for Bug Crowd a long time ago. So I still have some stock there. But I really like what they do in a couple ways. One, it gives people who would otherwise get into trouble something to do safely. So if you're somebody who would have just been joining like a, darknet crime, credit card group, something like that. Like, here's a different option. Maybe instead of getting arrested, you can go do bug bounties instead. And it's similar work. It's a lot safer. You can get paid a decent amount of money and you don't go to jail, which is nice. So I think it's great to offer that opportunity to the world to do this type of test in a way that's constrained. As far as the bounties themselves, I mean, one of the complaints that folks have with security testing is there's a common trope, which is like you don't want to hire the same pen test team every year because, they'll get lazy or they won't find stuff or you need a different approach, different eyes. So then folks will say, well, great. Well, how do I get the most eyes in my code and most eyes in my service? Well, you use crowdsource it. You get like 1,000 different people to try out different things, right? Hopefully one of them will find something different that someone else wouldn't find otherwise. And there's some truths in both sides, right? Like I tend to stick with the same uh, pen testing firm because I feel like, while they do have some of the same people on the test, they also rotate out some of the people. They also know a lot more about our stuff because many years later, they can go a lot deeper, a lot faster. So I feel like you actually save money by using the same firm because they can actually find a lot more because each time they can dig a little deeper than before. But that doesn't always work, right? If the firm that you normally do security testing with isn't that great, or it's not like one of the $50,000 to $100,000 week kind of firms out there, you're probably not going to get amazing results. You may actually get better results from a bug bounty program. So it's kind of like what do you get for your dollar? You may get more testing, you may get more people, you may get more ideas, and you also typically pay the platform some money to manage it all and to keep track of like, okay, this is real, not real, triage, not triage. So it's interesting for sure. I think there's very few companies that I think would not benefit from running a bug bounty program. We're kind of one of them right now. We're so small, but like we just don't have time to really support a bug bounty program too. We just, if someone finds a bug, they work, say that's awesome. Maybe a t-shirt, but we don't really have much else going on. We save our money to hire like a boutique firm once a year to really go super deep in the product instead, like way beyond the initial authentication. Go look at the source code, things like that. So that's the kind of testing that we prefer. Yeah, I think bug bounties are really good for, younger folks who are looking for a job and trying to get some initial revenue and learn the ropes, and also really good for companies who just need to have a lot of stuff and they're never going to be able to afford to hire a top tier firm to do everything. Like if you're a large telecom, you're a large Fortune 500, you have too many things for that to be affordable. You'd be spending like $500,000 on an audit. So if you turn around and spend $100,000 in bounties, it's actually cheaper for you and you may actually find more stuff.
Right. So, to speak in an builder point of view, if you had to build a new bug bounty platform, what is an unique proportion that you would think that's missing right now?
One angle that folks have been trying to take that's been partially helpful has been the kind of MSSP model, like where you actually deploy something inside the company site. So it's not just external. It's not just here's your domains or websites. It's actually you're deploying agents inside the company. So I believe Synac, I guess not Cobalt, it does that. I forget who bought who, but or who renamed who. But effectively, they will have an agent inside the company to do internal pen testing, not just external. You've got companies like Horizon 3 AI, which are doing these kind of like Docker containers. They spawn inside your environment and they do lateral movement testing, things like that. That's another way you kind of get the same way. I would definitely say like the thing you want to do is make sure you're not just testing external. Like you really want to be looking at the internal stuff and helping out the internal security teams with it what matters. Whether that's like testing out a web app before it goes live, whether that's doing an assessment of like an old kind of crufty network, like the old banking ATM network, trying to find things they might have missed. The challenge is the deeper you go into those companies, the more dangerous it gets. Like, if you take something offline, like an old HP 3000 host processor, like the company will no longer have ATM transactions that day. Like no one can withdraw money. So you can get things wrong very quickly. Or if you're working for, let's say, like a car manufacturer and you break the line, like the robots stop working. Well, you cost them millions of dollars just by getting one thing wrong. So the risk definitely goes up as you start doing that. But I feel like the internal side of kind of the bug bounty and crowdsource mode really is where folks are pushing these days, where I think there's probably more opportunity.
Right. That really makes sense because that's something which we often more don't we see on a public perspective because exposing an internal environment is very dangerous if it is not properly managed, of course. So yeah, I think that's a really interesting question that we can hustle with. Yeah. So going forward with some of the parts regarding AI. So see, coming up with a lot of different agents and LLMs and different set of protocols that is coming in and bringing in more agents to do a lot of automation stuff. But on the contrast, comparing about the GPUs availability and the cost of doing the activities, do you really see AI will go on a larger scale from what we are seeing right now, or will there be an downside of AI having this much of exposure in a lot of different products?
The The current commercials of the AI industry are awful. Like, you have a few players trying to just shovel money at it to buy the entire space. Like, OpenAI's a deal with NVIDIA is what's caused the price of RAM and NVMe cards to go up substantially across the world. So we now see, like, RAM costs have tripled just because NVIDIA sold majority or sorry, NVIDIA has bought most of the capacity for the memory manufacturers for the next 2 years. And so it's AI is kinda sucking the life out of the rest of the world at this point. Like, you can't get, like, you're gonna pay more for a video game console because of NVIDIA, like, because they're buying up all the capacity. So I think in the next 2 years, we're gonna see kind of they're really trying to turn into like a have and have nots. Everyone's trying to racing to be like, we have all the capacity, we have all the stuff. But I mean, my take is like that's all gonna age like milk, right? Within 2 years, the amount of CPU you need to or GPU to run these models will keep getting less and less. The models will get smarter. You won't need these giant resources anymore. You just have a bunch of empty data centers with 4-year-old GPUs in them that are now worth nothing. So to me, it feels like we're just setting ourselves up for a gigantic kind of disappointment and huge waste of money. So I just try to keep my head down. It's like if we can support somebody using AI with our product or with our customer stuff, great. Like we'll find a way to support an MCP server. We poke at models a little bit ourselves. We just don't feel like the economics are really there yet. We feel like most of the models are not dependable. They're definitely hard to control in different ways. They're definitely not safe. Like basically cross-site scripting all the way down with prompt injection. Like we're not in a place right now where I think these things are quite ready for prime time. And tons of people disagree with me, and they're all building security companies to use AI to do things that you may not be able to do otherwise scalably. But I don't feel like we're there yet. So I'm probably more conservative. I'll hang out another 2 or 3 years before I'll finally say, okay, now that LLMs are boring and you can just run one in the command line anywhere and they don't really cost many resources, yeah, maybe I'll start using them then. But I think right now, I don't like the idea of having to depend on a third party service to make any part of a product or system work.
Understood. That's really a great perspective. So, being in this field for a long run, so since this podcast is specifically focused to the people who is coming into the field and who is trying to explore a lot of different parts, what are some things that you would suggest people should not miss out? And a lot of people are not talking about that. So, insights on that lines.
I think probably the biggest misconception folks have this year is that you don't need to learn how to program. You can just make the AI do it, and that's not true. Like the AI is going to spit out a bunch of stuff. If you don't know how it works, you can't fix it. Like a lot of folks get into trouble pretty quickly. They start using LLMs to generate programs, and they say, "Look, I'm done. It's great." And then they realize it's completely wrong. The logic is broken. Like even if somebody writes code every day, still like if I use an LLM to generate a piece of code, like I can't tell if it's right or not without really, really looking at it. Like it's not easy to see those kinds of bugs. Everything looks plausible. Like everything looks like it's good code until you start taking it apart and realize it's completely broken, doesn't do what you'd think. So it's very difficult to like correctly code audit LLM generated code. And as a result, a lot of folks are now shipping bad code or they're putting off learning programming languages because they feel like they don't need to. And that's all going to come back and bite them. Like end of the day, it's like trying to be a painter and not knowing how to draw. Like you kind of have to do the basics first. You really can't, use a draw bot to drive the rest of your career. You really do have to just go learn it yourself. So, kind of my overall advice for people is always learn a programming language. Pick one. It doesn't really matter what Python, Ruby, Go, Rust, whatever. Just whatever it is, get really good at that one language and use that for everything you possibly can. Um, and then two is like, make sure you learn about the rest of the world, not just web apps, but the entire TCP/IP stack. Like, look at some of the cool things you can do with the network layer, layer two, layer three. What is a MAC address? How does ARP work? Like, how does IPv6 work in the real world? Like, those things are all still really important to security, but you don't see a lot of textbooks about them anymore because they're not exciting. They're not new, right? But they're still really critical to understanding how things work. So a lot of newer security courses really gloss over the entire networking stack. They really gloss over, how HTTP2 protocol works or HTTP protocol works. Instead, it's like, here's an application, here's a post request, a get request, whatever. It's like, that's great. But like, there's things you can do at the network level that allow you to do attacks at the application level. A good example is like all of the work that Port Swigger team and James Kettle did on HTTP, what do you call it? I
Smuggling,
forgot the term.
STV.
Yeah, the HTTP smuggling stuff. That was fantastic. That's a way to basically abuse like a layer four protocol into like then getting someplace you really shouldn't be in HTTP, which would make no sense at all if it wasn't for knowing more about the TCP side and the handoff and things like that.
Right. So this is all the questions that I had for you, and it was really great talking with you, getting on a lot of different perspective and insights. Thank you for joining the show.
Thank you, sir. Appreciate it.